What force could cause the Earth itself to tremble in rhythm with something far beyond its sky? In recent years, the ground has stirred with unsettling insistence. Earthquakes ripple across continents in numbers greater than expected. Some are minor, fleeting rumbles beneath cities and seas. Others tear open valleys and fracture the silence of mountains. Scientists chart the data, watching the graphs rise like the pulse of a restless heart. The crust of the Earth beats, not in chaos, but in a strange cadence. As though something distant were setting the tempo, it is here that the mystery deepens. For this pattern of seismic unrest seems to shadow a visitor that does not belong to this system, an object traced in the faintest strokes of starlight, a fragment from the abyss between suns. It carries the name 3I Atlas, the third interstellar wanderer humanity has ever seen. A body moving not with the slow inheritance of planetary orbits, but with the sharp trajectory of something born elsewhere, something untamed. The Earth quivers, and above, this alien fragment drifts ever closer to the sun. Coincidence, perhaps. Yet the question remains, growing heavier with each tremor beneath our feet. Could the foundations of this planet, hardened by billions of years, be responding to whispers carried across interstellar space? The silence of the cosmos is not empty. It holds secrets, and sometimes those secrets arrive uninvited. 3 Atlas has entered our story, and the Earth itself seems to know. It began, as such stories often do, with a faint thread of light against the black canvas of space. A trace so delicate that only the most patient instruments could discern it. Among the watchful eyes of Earth's robotic sentinels, the Atlas survey in Hawaii first caught the signal. Not a dazzling apparition, not a comet tearing across the night, but a subtle, flickering presence. A moving point of light whose path betrayed a truth stranger than most stars. This was not a child of our sun. Its orbit was not an ellipse bound to familiar gravity. It was a curve from elsewhere, plunging inward at a speed no planetary body could sustain. Its designation became 3I Atlas, the third interstellar object ever found, after the enigmatic Oumuamua and the icy wanderer 2I Borisov. A new emissary from the abyss between the stars. Oumuamua had unsettled astronomers with its peculiar shape, its inexplicable acceleration, its silence where a comet's voice of dust and gas should have been. 2I Borisov was more familiar, a cometary traveler carrying the frozen chemistry of another system, its tail bright and obvious. But 3I Atlas was different still. Its light flickered in ways that suggested instability. Its brightness rose, then fell, as if pieces of it were beginning to fragment, as if something within it stirred awake. Telescopes like Pan-STARRS, Atlas and Neowise tightened their focus, gathering the faint clues that photons carry across millions of kilometers. They measured its trajectory, calculated its hyperbolic path, and confirmed it bore no allegiance to the sun. This was an intruder, unbound, passing through the solar system as a messenger of distant origins. The metaphor is inescapable. 3I Atlas behaved like a sleeper roused from a long silence. In the deep cold between stars, it had drifted for ages, perhaps since the birth of another sun, perhaps since the ruin of another world. There, frozen and inert, it carried the memory of its home system like a sealed relic. Yet as it fell toward our sun, the warmth of starlight touched it, and the object seemed to awaken. Brightness surged. Gases may have vented. Fragments appeared to peel away. To some, it looked less like a stone and more like a living thing responding to a call, and the call was gravity. Stellar gravity, insistent and unrelenting. The sun's pull is the voice that awakens every comet. But with 3I Atlas, the awakening carried more mystery than certainty. Was it merely the physics of ice sublimating into vapor, or did its strange, uneven brightening point to something we had not yet seen? Scientists compared notes. Oumuamua had taught them that not every visitor will fit the molds of comets or asteroids. Its elongated body, its non-gravitational acceleration, had raised more questions than answers. Borisov, in contrast, was comfortingly familiar, its behavior predictable. But 3i Atlas refused such categories. Its light curve flickered with hints of fragmentation, like a relic too fragile to survive the intimacy of sunlight. At times, it seemed to glow brighter than it should. Then, without warning, it dimmed again, as though the abyss itself had given it a heartbeat. Astronomers asked what this meant. Was 3i Atlas simply crumbling, another fragile traveler undone by the heat of a star? Or was its brightness revealing deeper mysteries, differences in composition, hidden pockets of volatile ices, or structures shaped in the birth throes of some forgotten system? Speculation stretched further, beyond what data could confirm. Some called it an awakening, a dormant traveler stirred after eons of silence. Others wondered if its unstable behavior hinted at a journey more complex than gravity alone could explain. What histories had it carried across interstellar space? What collisions? What planetary systems? What cataclysms had flung it free and sent it drifting here? And still, the telescopes watched. Neowise captured faint infrared echoes. Atlas charted each shift in brightness. Pan-stars traced its arc against the stars. Every photon was data. Every flicker was a clue. Yet the more humanity studied the intruder, the more it seemed to resist clarity. Atlas became a mirror, reflecting both the precision of science and the limits of human knowledge. It reminded astronomers that each discovery of an interstellar visitor is not just a data point, but a confrontation with the unknown. For in these brief encounters, humanity is granted glimpses of matter that was never meant to belong to this system. In the language of philosophy, one could say the abyss itself had whispered. And the whisper took the form of light, faint and flickering, carried by an intruder whose path brushes close to our sun before vanishing back into darkness. What does it mean when a fragment from another world seems to awaken as it nears ours? Is it chance? Or is it a reminder that even in the silence between stars, nothing is ever truly still? 3i Atlas drifts on, luminous and fragile. Its journey tells a story written in the cold of interstellar night and rewritten now by the warmth of a new star. For a brief moment in cosmic history, it is here, and Earth, with its restless quakes and curious watchers, feels the presence of the intruder from the abyss. The Earth speaks most clearly when it shakes. Its voice is not gentle. It is a low roar that begins beneath the surface, then rises through stone, soil, and city until walls sway and oceans ripple. For as long as humanity has walked upon it, the ground has never been silent. Yet in recent years, the patterns of this voice have begun to change. Seismographs scattered across the globe measure every vibration, every sudden movement of the crust. They tell stories in graphs of jagged lines, and those stories are now growing more numerous, more intense. From the trenches of the Pacific to the shifting scars of Turkey, from the trembling coasts of South America to the long fractures beneath Alaska, the frequency of earthquakes has begun to climb. Some are small, scarcely felt but recorded with precision. Others are catastrophic, tearing through cities and landscapes with destructive force. The data show more than isolated incidents. Seismologists have noted clusters of events where one quake seems to follow another, not always along the same fault line, but in strange echoes across continents. In Mexico, tremors repeat with curious regularity. In the South Pacific, swarms of quakes rise from depths no one had expected. In places where seismic silence was once the norm, the ground now stirs with a disquieting rhythm. To place this in context, scientists compare present records with the deep archives of the past. Earthquakes are ancient companions of this planet. Plate tectonics, the grand engine of shifting continents and rising mountains, has always driven them. When plates collide, pressure builds. When plates slide, tension snaps. Fault lines release their burden in sudden bursts of energy. This has been the cycle for hundreds of millions of years. Yet even against this long backdrop, the present spikes stand out. Historically, the Earth averaged a steady cadence of strong quakes, a baseline etched into seismological charts since global monitoring began in the 20th century. Now the graphs bend upward. Between 2000 and 2020, the number of significant earthquakes appeared to increase, with years of unusual clustering. Scientists debate whether this rise is a true change in the Earth's behavior or an artifact of better detection technology. Modern networks are more sensitive than ever before. Instruments can register vibrations so faint they would have gone unnoticed a century ago, but better detection does not fully explain the timing. For even with adjustments, anomalies remain. Years appear when earthquakes surge in number and power, followed by stretches of uneasy calm only to surge again. The Earth seems to breathe in long, uneven sighs of seismic unrest. Natural explanations offer some comfort. Seismic swarms can result from magma rising unseen beneath volcanic regions. Aftershocks often ripple after a single catastrophic rupture, painting the illusion of multiplication. Tidal forces from the moon add a subtle pull, sometimes tipping stressed faults into motion. Even human activity, deep drilling, fluid injection, the extraction of resources, can awaken faults that had long slumbered. And yet, some patterns linger stubbornly outside these explanations. Earthquakes have appeared to synchronize across vast distances, quakes in Asia resonating with quakes in South America, separated not by faults but by oceans. Some swarms emerge in regions where plate movements offer no obvious cause. There are moments when the Earth seems to act as though responding to a signal larger than itself. This is where speculation enters, tentative but compelling. Some scientists and philosophers have asked whether seismic activity might correlate not only with tectonic strain, but with cycles written into the cosmos itself. For decades, researchers have studied how solar activity influences Earth's magnetic field and atmosphere. Solar flares, coronal mass ejections, and cycles of sunspot intensity all press upon our fragile planet. The data show that geomagnetic storms can disturb satellites, power grids, and even the migratory paths of animals. Could they also stir the fragile balance of tectonic stress beneath our feet? Studies remain divided. A handful of statistical analyses have suggested faint links between peaks of solar activity and clusters of earthquakes. Others dismiss such connections as coincidence, artifacts of human pattern seeking. But the questions persist, for Earth's crust is not an isolated machine. It is part of a system bathed in cosmic energy, stretched by the moon, warmed by the sun, and bombarded by particles from the stars. Into this tension enters a new possibility. As astronomers track interstellar visitors like 3I Atlas, they ask whether the rhythms of Earth might align with events beyond the solar system. Could gravitational perturbations, however slight, ripple into tectonic unrest? Could the electromagnetic wake of passing bodies amplify stresses already at the breaking point? These remain questions without answers, yet they ignite curiosity because of timing. For as 3I Atlas drifts closer to the sun, seismic anomalies appear in charts with renewed vigor. The idea that the Earth could tremble in sympathy with a fragment of matter born beneath another star stretches imagination. But it is not without precedent in human thought. Ancient cultures often linked earthquakes to celestial omens. The ground was not separate from the sky. The two were woven into one tapestry of fate. Now, armed with seismographs and space telescopes, humanity asks similar questions in a new language. The cosmic correlation, as some call it, remains speculative. No conclusive proof binds the tremors beneath our feet to the path of an interstellar traveler. Yet the suspicion lingers like a shadow. Patterns whisper in the data. Quakes cluster when they should not. Brightness flickers in the intruder as the Earth's crust stirs below. Science demands restraint, but imagination steps forward, compelled by the possibility that Earth itself may be listening. The tremors remind us of a deeper truth. The planet is alive in ways not fully measured. Beneath continents and seas lies a restless mantle, shifting, grinding, pressing outward. Earthquakes are its heartbeat, sometimes steady, sometimes erratic, but never silent. And if that heartbeat aligns, even faintly, with the movements of stars and visitors from the abyss, it would suggest a connection far greater than humanity has yet understood. In the end, one truth is certain: the Earth trembles more often now. Its voice grows louder, its rhythm more complex. Whether the cause lies in tectonic stress, in the sun's restless cycles, or in whispers carried by interstellar fragments, the effect is undeniable. Cities feel it. Oceans feel it. Humanity feels it. The Earth is speaking. The question is whether it is speaking only to itself, or to the cosmos that surrounds it. At the heart of the solar system burns a star that has never known silence. The sun, ancient and unyielding, is a furnace of plasma where the very fabric of matter is torn apart and reassembled. Deep in its core, hydrogen is pressed so tightly that it fuses into helium. With every reaction, light is born. That light journeys outward, taking tens of thousands of years to pass through the star's dense layers before spilling into space as the warmth and brilliance that sustains life. The sun is more than a source of light. It is a vast and restless machine of physics, a place where plasma churns in convective currents, where magnetic fields twist and break, and where storms the size of worlds erupt with little warning. Dark blemishes appear on its surface, the sunspots, cooler regions carved by tangled fields of magnetism. From these regions, flares burst forth, colossal arcs of charged particles and radiation that hurl themselves across the void. These flares are not gentle. They release as much energy in minutes as billions of nuclear bombs, and their echoes sweep outward to the planets. When aimed at Earth, they collide with the planet's magnetic shield, rattling it like a drum. Auroras flare in ghostly greens and reds at the poles, a reminder of the beauty hidden within violence. But there are dangers too. Geomagnetic storms triggered by the sun can disrupt satellites, disable power grids, and distort radio signals. In 1989, a solar storm collapsed the electrical network of Quebec. In 1859, the infamous Carrington event set telegraph wires ablaze. Earth is tethered to the moods of its star, yet the sun itself dances to deeper rhythms. It follows an 11-year cycle of activity, a waxing and waning of sunspots and storms. At the height of the cycle, the star's surface becomes a battlefield of erupting plasma. At its minimum, the surface calms, though never completely. Humanity has lived beneath these cycles for millennia, but only in recent decades has it begun to understand their profound reach. It is here that the story folds into speculation. For as astronomers tracked 3I Atlas drifting inward, whispers arose about its influence. Could the passage of an interstellar body disturb the sun itself? On the surface, the notion seems improbable. A fragment of rock or ice, no larger than a mountain, holds no power to rival a star that outweighs Earth by a factor of 300,000. Yet physics is not ruled by size alone. Gravity, though faint, stretches without end. Magnetic fields resonate across the emptiness. Even the smallest intruder, moving with the speed of the abyss, may leave behind a trace in the invisible architecture of space-time. Einstein's theory of relativity revealed that mass and motion warp the very stage upon which the universe unfolds. A star curves the geometry of space-time around it. A planet falls into that curve, following its invisible tracks. Even a traveler as small as 3I Atlas is a player upon this field, altering it in ways too subtle for ordinary eyes to see. Hawking reminded us that the cosmos is never static, that every object is both a participant and a witness in the great weave of gravitational ripples. So the question lingers. As 3I Atlas slips near the sun, does it leave behind disturbances that ripple into the star's magnetic shell? Could its passage nudge the tangled loops of plasma that twist above the solar surface, perhaps awakening storms that would otherwise remain unborn? No instrument yet confirms such a link, yet the timing unsettles. For as the intruder approached, the sun's activity seemed to climb. Sunspots multiplied, Flares intensified, and the star's corona erupted in bursts that lit up the magnetosphere of Earth. Perhaps it is coincidence, a reminder that cycles often align without cause. Yet coincidence itself can be a kind of riddle, pressing humanity to ask questions it has not yet answered. For in the deep history of science, new truths have often been born from curiosities dismissed as chance. The metaphor takes shape. The sun, long slumbering at the quiet end of its cycle, now appears to awaken. Its restless face grows turbulent. Its flares claw at the void with renewed violence. To the human imagination, it is as though the intruder from the abyss has whispered across the gulf of space, and the star has stirred in reply. The reality may be simpler. The sun is never still. Its heart beats with fusion, its skin ripples with storms, and its magnetism snarls in patterns that defy easy prediction. Yet the timing cannot be ignored, for it weaves into the larger mystery. Earth's quakes, the trembling crust, the flickering of an alien fragment, and now the star's growing unrest. Could it be that these events are threads of one tapestry, woven across scales too vast for immediate comprehension? Or are they separate, the product of a human mind seeking meaning in coincidence? The answer for now eludes certainty. What remains is the tension, a star that seems to wake, a visitor that passes close, and a planet that trembles beneath their gaze. The sun has always been restless. It was restless before 3i Atlas appeared, and it will be restless long after. But in this moment of cosmic encounter, its storms feel heavier with meaning. The Earth feels their touch. Humanity watches with unease. The question grows louder. Is this only the rhythm of physics, or is it the echo of something greater, stirred awake by the presence of a foreign visitor? The abyss does not answer. The sun burns on, brilliant and untamed, its core fusing atoms into light, its surface erupting with storms. Yet in the silence between its flares, the mystery endures. The universe is bound together by forces that cannot be touched, forces that move unseen through the fabric of existence. Gravity and electromagnetism are the invisible architects, shaping the paths of stars, the rhythm of planets, and the delicate balance of life on Earth. They are whispers that guide the cosmos, faint yet inexhaustible, silent yet undeniable. Gravity was once thought to be simple, a pull exerted by mass, an attraction between bodies. Isaac Newton described it as a force that reached across space instantaneously, binding the moon to the Earth to the sun, and the stars to the infinite canopy. For centuries, his law explained the motions of the heavens with exquisite precision. Yet Newton himself admitted he did not know why such a force existed, only that it was written into the clockwork of the universe. Centuries later, Albert Einstein reframed the mystery. Gravity, he revealed, is not a force at all, but the warping of space-time itself. Mass bends the geometry of reality, and objects follow the curves of that bending. A star's gravity is not a pull, but a valley carved into the invisible fabric of existence, a valley down which planets roll in their orbits. Space and time are not passive stages. They are pliable, elastic, and alive with curvature. In this light, every object, from the smallest stone to the mightiest star, reshapes the cosmos around it. Earth itself curves space, holding the moon in its embrace. The sun bends space-time so profoundly that even beams of starlight curve as they pass near it. And a fragment like 3i Atlas, though minuscule compared to a star, still leaves its trace. It reshapes space-time by the smallest fraction, its hyperbolic path carving a ripple into the geometry of the solar system. The question becomes one of resonance. Could these curvatures align, like waves amplifying one another? Resonance is a principle of nature, a quiet law that magnifies the smallest inputs into great effects. A swing pushed at the right rhythm soars higher with each touch. A bridge struck by a matched vibration can shudder to collapse. In the vastness of space, the alignments of worlds, stars, and interstellar fragments may produce similar resonances. Gravity may seem faint, but in resonance, faintness can become thunder. Some theories suggest that alignments of planets can subtly shift tectonic stresses on Earth. The gravitational pull of Jupiter and Venus, though distant, has been modeled to exert measurable tides upon the Sun itself, modulating its cycles of activity. The Moon's tidal forces are already known to nudge faults toward rupture, triggering quakes when the Earth is already near the breaking point. Might there be a deeper pattern, where celestial alignments resonate through space-time to stir the very crust beneath our feet? Beyond gravity lies another whisper, one no less powerful. Electromagnetism is the force that sculpts the sun's storms and binds the magnetic shield of Earth. Every second, the sun hurls charged particles outward in the solar wind, a stream of plasma threading the void. When these particles encounter Earth's magnetosphere, they compress it, shake it, and sometimes pierce it. Magnetic reconnection, the sudden rearrangement of field lines, releases bursts of energy that can reverberate across the globe. The planet responds. Auroras blossom in shimmering curtains, a silent ballet of light above the polar skies. Power grids shudder under surges of induced current. Radio waves falter. And in the deep crust, some researchers suggest, these magnetic tremors may influence seismicity, not by raw force, but by subtle modulation of stresses already primed to fail. Case studies offer intriguing hints. The Great Solar Storm of March 1989 coincided with a cluster of unusual seismic events. Analyses of past solar cycles reveal periods where intense solar activity overlapped with upticks in earthquakes, though the statistical significance remains contested. Some scientists caution against drawing connections too quickly, reminding that the Earth is complex, its tectonics chaotic. Yet the patterns invite speculation, and the speculation refuses to fade. In recent decades, advances in satellite observation have revealed how intimately Earth and Sun are entwined. Magnetometers record the ripples of geomagnetic storms with exquisite detail. Space-based observatories trace the flow of particles from coronal holes and solar flares. Seismologists compare their records, noting curious synchronies between solar outbursts and terrestrial tremors. The whispers between Sun and Earth are faint, but they are there, written in data waiting to be interpreted, and now, into this dialogue, enters 3I Atlas, an interstellar body of unknown origin, carrying with it magnetic and gravitational signatures unlike those of our solar system. Its approach may be too distant to cause measurable tides or magnetic surges on its own, yet its presence alters the equations. Its mass curves space-time ever so slightly. Its speed and charged particles interact with the solar wind in ways not yet modeled. It becomes, in essence, a new participant in the cosmic conversation. Theorists imagine hidden dialogues, exchanges of force and resonance between Sun, Earth, and the visitor. Not conversations in words, but in ripples of curvature and currents of charged particles. A solar flare ignites, geomagnetism trembles, and the Earth shakes. Was the flare inevitable, or was it nudged into being by a delicate realignment of cosmic geometry, a new body crossing invisible threads of resonance? Science does not yet answer. Philosophy asks the question anyway. The image grows more profound when viewed through Einstein's lens. Every mass, every field, every wave of energy is part of a single continuum. Space-time is not empty, but alive with curvatures and vibrations. In that continuum, nothing is isolated. The trembling of Earth's crust, the flicker of an interstellar fragment, and the storming of the sun may be distant events. Yet all are bound by the same invisible threads. Hawking once wrote of the universe as a grand conversation, a dialogue written not in language but in mathematics. If that is true, then perhaps what we see in 3I Atlas is not an intruder but a messenger. Its presence reminds us that Earth, Sun, and the abyss beyond are not separate realms, but interwoven domains of one vast symphony. Still, the mystery remains unresolved. Theories of resonance and electromagnetic influence invite the mind to wonder, yet the data remain incomplete. Earth trembles, the sun flares, the intruder brightens, and humanity watches. Are these events connected, or is the connection only in the human eye seeking meaning? The answer may not matter as much as the question. For the act of asking draws humanity deeper into the cosmic fabric, closer to understanding that nothing, not even the silence between stars, is ever truly empty. Invisible threads bind all things, threads that whisper across space-time, carrying messages we are only beginning to hear. The Earth is more than a sphere of rock and water. It is a resonant body, a vast instrument of stone and fluid, tuned by forces both near and far. Its crust, its oceans, and its molten core are not silent. They hum with vibrations too deep for human ears. A hidden music recorded in the slow sway of tectonic plates, in the rise and fall of tides, in the delicate oscillations of its magnetic field. To scientists, Earth behaves like a living seismograph. Every collision of waves, every tremor beneath the mantle, every whisper of gravity from the moon or the sun leaves a trace. These traces build into rhythms that reveal the planet's hidden conversations with the cosmos. The most familiar of these dialogues is tidal. The moon, in its steady orbit, exerts a gravitational pull that lifts oceans into waves of unimaginable mass. Each day, the seas rise and fall in response to this call, sculpting shorelines, guiding the migrations of life, and subtly straining the crust itself. Even the solid Earth responds, rising by centimeters beneath the moon's gaze before settling again as it passes. The sun adds its own pull, deepening or softening the tides, weaving its gravity into the fabric of Earth's daily breath. But tides are not only oceans. They are forces that echo through rock and magma. They twist fault lines by imperceptible degrees, storing tension until one fracture yields, releasing an earthquake. Many of Earth's greatest tremors have coincided with tidal peaks, moments when lunar and solar gravity conspire in alignment. It is not that tides create earthquakes, but that they act as triggers, striking the resonant body of Earth when it is already primed to break. The resonance extends deeper. Earth itself rings when struck by great events. The largest quakes send waves pulsing around the globe, oscillations that can be measured for weeks as the planet shudders in subtle aftertones. Seismologists call this free oscillation, the Earth singing like a bell after a blow. It is a reminder that the planet is not inert but vibrational, alive with hidden harmonies. These harmonies may not be confined to the moon and the sun. Some researchers wonder whether Earth's resonant body also responds to more distant chords. The cycles of solar activity, maxima and minima marked by sunspots and flares, appear to leave echoes in seismic records. When the sun erupts with storms, Earth's magnetosphere shivers. The crust, already burdened with stresses, sometimes responds in kind. Correlations have been observed, though the mechanisms remain unclear. Are they coincidence, or are they signs that Earth resonates with the rhythms of its star? Here speculation turns outward, toward the abyss. If the Earth can resonate with its sun, can it also resonate with the passage of an interstellar traveler? 3i Atlas moves not with the steady rhythm of the moon nor the recurring cycle of the sun, but with the silence of deep time. Its gravity is weak compared to a star, yet it is real. Its electromagnetic signature, carried in interaction with solar wind, is faint, yet it exists. Could such influences strike chords within Earth's resonant body, not with the force of a blow, but with the subtlety of a note plucked on a string? In this metaphor, Earth becomes an instrument strung between forces, its crust, oceans, and core vibrating in sympathy to invisible chords played across space. The moon plucks the strings daily. The sun adds its grand symphonic cycles, and the passage of an interstellar visitor might contribute a new, unfamiliar note, one that trembles through the system in ways not yet measured. Emerging science seeks to test these possibilities. Networks of seismographs linked across continents now detect tremors smaller than the motion of a hair. Satellite systems track the slightest rise and fall of the crust, revealing how Earth deforms under tidal and solar influence. Magnetic observatories log the planet's shifting shield in response to solar wind. Together, these instruments transform Earth into a recorder of cosmic resonance, a sensor tuned to both its immediate star and to the whispers of the greater galaxy. Some researchers propose models of resonance that treat Earth as a complex oscillator. In these models, the planet's crust, mantle, and core interact like overlapping waves. When external forces strike at frequencies close to these natural modes, the vibrations may amplify. The result could be heightened seismicity, subtle shifts in climate patterns, or even changes in the flow of the core's molten iron, which generates the magnetic field itself. Skepticism remains. Many argue that Earth's internal forces are too vast, too chaotic to be swayed by faint cosmic whispers. Yet others suggest that resonance is precisely the mechanism by which small forces can matter. A swing pushed by the smallest hand grows in amplitude when the timing is right. A glass shatters not by weight but by vibration at the frequency it cannot resist. Earth may be no different. Philosophically, the idea is profound. It paints a picture of a planet not as an isolated world, but as a participant in the music of the cosmos. Earth sings because the cosmos plays upon it. Invisible threads of gravity and magnetism tie it to the moon, to the sun, and perhaps even to visitors from beyond the stars. The image is haunting. Earth is a resonant body, trembling with the touch of tides, humming with the voice of the sun, and now stirred by the passing of 3 Atlas. A fragment from another star system, drifting through, its presence barely visible, yet perhaps leaving its echo in the vibrations of our world. If the Earth sings, then humanity is only beginning to hear its song. Instruments now act as ears pressed to the ground, translating vibrations into knowledge. Each tremor, each tide, each oscillation is a note in the score. Scientists listen for patterns, searching for evidence that Earth's resonances align not only with familiar cycles, but with the whispers of the greater universe. The mystery endures. Earth trembles, oceans rise, and the crust rings with seismic echoes. The question is not whether it resonates, for it surely does. The question is with whom it sings, and what chords are being struck by the unseen hands of the cosmos. Every mystery invites explanations. When the skies reveal a fragment like 3i Atlas, luminous and unstable as it nears the sun, science seeks causes. It asks why the intruder brightens and dims, why its body seems to fracture, why its presence coincides with turbulence both above and below the Earth. The search for answers is a chorus of voices, some rooted in physics and chemistry, others wandering into the speculative and the ancient. The first explanations are grounded in cometary science. Most interstellar visitors are expected to behave like comets, icy relics hurled from distant planetary nurseries. Their cores are mixtures of frozen water, carbon dioxide, methane, and dust. For eons in interstellar night, these ices remain inert, locked in silence. But when the warmth of a star touches them, they sublimate, erupting into jets of vapor that scatter dust into tails and comas. This outgassing can make a body brighten suddenly, as though awakening from slumber. It can also tear fragments away, leaving the object unstable. Many astronomers interpret 3i Atlas's erratic light curve in this way, a fragile cometary core crumbling under the touch of sunlight. Other theories reach into subtler forces. Radiation pressure, the momentum carried by photons themselves, can push against small bodies in measurable ways. This effect is invisible but real. It may explain why Oumuamua, the first known interstellar visitor, accelerated slightly as though propelled by something other than gravity. Some wondered whether it was a thin fragment, light enough for starlight to nudge. Others suggested exotic possibilities, from hydrogen icebergs sublimating to artificial sails. With 3i Atlas, radiation pressure is considered again, perhaps amplifying its fragmentation, perhaps altering its path. Still others speculate on gravitational effects. The sun is not only a furnace of plasma, but also a lens of gravity, bending space around it. As 3I Atlas moves through this curvature, it experiences tides of force that may destabilize its structure. Some wonder if such gravitational interactions extend beyond the object itself, rippling outward to touch Earth. It is a bold speculation that a fragment drifting past the sun could serve as a catalyst, its motion aligning with fields and resonances in ways not yet mapped. Could it act as a lens for cosmic forces, focusing subtle disturbances upon our planet? From magnetism arises another possibility. Interstellar objects are not necessarily inert. They may carry remnant magnetic fields, relics of the stars that birthed them. As they collide with the solar wind, they may disrupt its flow. In theory, such disturbances could ripple into the heliosphere, adding turbulence to the magnetic environment of Earth. It is conjecture, but it reflects the growing recognition that the solar system is not an isolated bubble. It is immersed in a galactic sea, and every visitor stirs that sea in its passing. Beyond mainstream science lie the fringes. Plasma cosmology, though largely set aside by modern astrophysics, proposes that cosmic plasma currents shape galaxies and stars more profoundly than gravity alone. In this view, interstellar objects might be charged nodes, interacting electrically with the sun. Though most scientists regard such claims with skepticism, the imagery resonates, filaments of plasma stretching across the cosmos, linking stars, planets, and fragments in a hidden circuitry. Other fringe ideas suggest that solar storms themselves might trigger earthquakes. Electromagnetic surges from flares and coronal mass ejections penetrate Earth's magnetic field, inducing currents that strain the crust. Some analyses claim correlations between solar maxima and spikes in seismic activity. The evidence remains debated, yet the possibility lingers in scientific literature, a hypothesis not fully dismissed. If such links exist, then an object like 3I Atlas, by stirring solar activity, could indirectly echo in Earth's trembling ground. These speculations carry an ancient resonance. Long before telescopes and satellites, civilizations gazed upward and sought meaning in celestial signs. The Babylonians read the skies as messages of destiny. The Chinese recorded comets as harbingers of upheaval. In Mesoamerica, eclipses were feared as precursors of disaster. Earthquakes, too, were often linked to the heavens, the trembling ground as a response to the movement of gods and stars. To ancient eyes, the cosmos and the Earth were one continuum, and disturbances in the sky inevitably echoed below. Modern science separates myth from mechanism, yet the echoes persist. Humanity, with its instruments, finds itself returning to similar questions, though framed in equations and data rather than prophecy. Could the approach of a foreign object truly be entwined with Earth's unrest? Or are these patterns illusions, coincidences that arise from the human mind's hunger for order and chaos? Pattern recognition is both a strength and a danger. It guides science to discover laws, but it also tempts imagination to see connections where none exist. Earthquakes happen often, the sun is always restless, and interstellar visitors are rare but inevitable. To link them may be to weave a narrative from noise. Yet narratives have power, and sometimes within them, truths are revealed that raw data alone cannot see. The balance lies in skepticism. Science demands restraint, demanding proof before belief. But it also thrives on curiosity, on the courage to explore unlikely connections. In the case of 3I Atlas, both forces are at play. Seismologists sift through quake records, solar physicists model flares, astronomers track the fading light of the intruder. Theories clash, some dismissed, some refined, all contributing to the search for understanding. The awakening of 3I Atlas may be nothing more than a comet's death throes, an icy fragment dissolving in sunlight. Or it may be more, a reminder that Earth is not an island but a resonant body in a cosmos alive with invisible interactions. Whether by gravity, magnetism, or coincidence, the passage of the intruder stirs questions that reach far beyond its fleeting presence. Theories multiply. Explanations diverge. But at their heart lies the same mystery. Why does this small fragment from another star feel so entangled with the trembling of our own world? The answers remain uncertain, suspended between the rigor of science and the allure of patterns glimpsed in chaos. And so the story deepens. Three-Eye Atlas drifts on, fragmenting, brightening, dimming, perhaps dissolving. Earth trembles, the sun storms, and humanity continues to wonder. The awakening may be cometary physics. It may be cosmic resonance. It may be something stranger still. What is certain is that the questions it raises are as profound as the abyss it came from. The mystery of Three-Eye Atlas, of trembling earth and restless sun, is not witnessed by human eyes alone. It is traced by instruments, machines that stand as humanity's extensions into realms once invisible. These tools are the watchers of the watcher, guardians of perception that allow fragile minds to glimpse the vast patterns written in space, in stars and in the trembling ground beneath. The story of this pursuit begins with telescopes. On the volcanic slopes of Hawaii, the Atlas survey scans the skies each night. Its name, the Asteroid Terrestrial Impact Last Alert System, reflects its mission: to detect what might come rushing toward Earth before it arrives unannounced. Wide-field cameras sweep the heavens, catching the faintest flickers of motion against the stillness of stars. It was here, within Atlas's nightly harvest of images, that the fragment later named Three-Eye Atlas was first discerned. Not as a blazing herald, but as a subtle shift, a dot of light whose orbit betrayed that it came not from within, but from beyond. Nearby, Pan-STARRS, the Panoramic Survey Telescope and Rapid Response System, continues the vigil. With mirrors spanning nearly 2 meters and cameras capable of imaging the entire sky several times each month, Pan-STARRS captures the drifters and wanderers, the comets and asteroids, the intruders from the abyss. It too had first recorded Oumuamua, that elongated enigma, and now it sharpened its gaze upon Three Atlas, tracking its arc and its flickering brightness with precision. Together, Atlas and Pan-STARRS form part of Earth's first defense against cosmic surprise. And in their data, the whispers of the interstellar object are preserved. But to study not just the intruder, but the stage it crosses, other watchers turn their gaze toward the sun. The Solar Dynamics Observatory, launched by NASA in 2010, hovers in geosynchronous orbit, recording the star in multiple wavelengths. Its eyes capture the magnetic ballet of loops and arcs, the dark scars of sunspots, the violent bursts of flares. Each image is a reminder that the sun is not a placid orb, but a storm of plasma and magnetism, shaping the very conditions of life on Earth. From SDO's vantage point, correlations between solar restlessness and Earth's trembling ground can be studied in exquisite detail. Deeper still ventures the Parker Solar Probe, humanity's first emissary to the sun's corona. Skimming closer than any spacecraft before, Parker dives into the furnace of solar wind, sampling particles and fields directly. Its instruments reveal the mechanisms by which the sun hurls matter into space, matter that later collides with Earth's magnetic shield. If there are subtle changes, faint disturbances triggered by the passage of interstellar fragments like Three-Eye Atlas, Parker may be the tool to reveal them, yet not all watchers gaze upward. Across the continents, seismographs form a global network that listens instead to the Earth itself. Sensitive instruments buried deep in quiet ground record vibrations smaller than the width of a human hair. They chart the sudden ruptures of faults, the long rolling echoes of aftershocks, the hum of the Earth's free oscillations. Each quake becomes part of a global conversation, stitched together into a tapestry of motion. If Earth resonates with the rhythms of the sun, or trembles in sympathy with cosmic visitors, these seismographs are the first to know. Beside them, magnetometers monitor the planet's invisible shield. They register the arrival of solar storms, the surges of geomagnetic activity that ripple through the ionosphere. In combination with space-based detectors, they allow scientists to forecast space weather, to warn when satellites or power grids may be at risk. Space weather prediction models have grown more sophisticated, weaving together solar images, plasma readings, and geomagnetic indices. In these patterns, some see only the complex interactions of star and planet. Others glimpse hints of deeper correlations, where tremors below coincide with storms above, where Earth and Sun seem bound in resonance. The pursuit of such connections demands patience. Scientists sift through oceans of data, seeking threads so faint they risk dissolving into noise. They chart timelines of quakes beside solar cycles, overlay sunspot counts with tremor magnitudes, compare the approach of interstellar fragments with the rhythms of Earth. Most correlations vanish under scrutiny, casualties of coincidence, but a few remain, stubborn enough to invite further study. It is in these remnants that speculation finds its foothold, that whispers of cosmic resonance refuse to fade. The tools of today are remarkable, but greater eyes are coming. The James Webb Space Telescope, though designed to peer at galaxies and the birthplaces of stars, may yet contribute by revealing the chemistry of interstellar wanderers, their icy surfaces and volatile cores. Its infrared gaze can dissect the faintest glow of molecules released as such objects near the sun. In Webb's data, humanity may learn whether 3I Atlas is a fragment of a shattered world, a messenger from a newborn star, or something stranger still. Future solar probes will fly closer into the corona and beyond, unraveling the hidden mechanisms of storms that may one day be linked to seismic unrest. Earth-Sun observation satellites, stationed at stable points in space, will provide continuous watch over both star and planet, creating a seamless stream of data that spans from core to corona. The vision is of a living system monitored as one, Sun, Earth, and interstellar environment woven together in observation. The more instruments humanity builds, the clearer the patterns become, yet the mystery does not fade. Instead, it grows more intricate. Every new telescope reveals new complexity. Every new seismograph uncovers fresh anomalies. The Earth trembles, the Sun storms, the interstellar fragment flickers, and the watchers record it all. What they capture are pieces of a larger puzzle, a puzzle not yet solved but felt in the rising weight of questions. There is poetry in this pursuit. Machines built by human hands, stationed on mountains, buried in stone, or launched into the void, are themselves part of the Earth's resonance. They extend its senses, amplifying its ability to perceive the cosmos. In their silent work, the watchers transform chaos into meaning, even if the meaning remains elusive. To watch the watcher is to recognize that humanity does not stand apart from the cosmos, but within it. Each telescope, each seismograph, each satellite is a mirror, reflecting the desire to understand the connections that bind all things. Perhaps the correlations found are only patterns in chaos. Perhaps they are signs of a deeper resonance, a hidden dialogue between Earth, Sun, and the wanderers of the abyss. What is certain is that the watchers remain vigilant. Atlas scans the sky. Pan-STARRS tracks the faint intruder. Steo and Parker probe the restless sun. Seismographs listen to the trembling ground. Webb opens its golden eye upon the universe. Together they stand as humanity's ears and eyes, seeking the whispers that might reveal whether Earth truly sings in response to the cosmos. The intruder drifts on, and the watchers follow. The Earth trembles, and the watchers listen. The sun erupts, and the watchers measure. Always the tools extend further, chasing the mystery with unrelenting patience. For in the act of watching, the unknown becomes a little less distant, and the invisible threads that weave Sun, Earth, and interstellar space begin to reveal their shape. The story of 3I Atlas, of trembling Earth and restless Sun, is not merely a record of distant physics. It is a mirror, a reminder that to observe the universe is never a neutral act. For in every observation lies participation, and in every measurement lies reflection. Humanity gazes outward, yet what it sees returns inward, revealing not only the cosmos but itself. The earth trembles. The sun erupts. An interstellar fragment drifts through, luminous and unstable. These are not abstractions. They are realities that shape the lives of a fragile species. Civilizations rise upon crusts that shift. Cities grow upon ground that moves. Entire histories are written in the silent intervals between quakes, in the calm years when the earth seems steady, though it never is. The ground beneath is alive, restless, unpredictable, and still, humanity builds, reaching for permanence against impermanence. Above, the sun burns with a power that sustains life, yet holds within it storms that could undo the fragile networks of a technological age. Satellites that carry voices, grids that feed cities, instruments that guide navigation, all are vulnerable to the invisible tides of solar winds. The same star that gives warmth and light can strip away the veil of stability with a single eruption. To live on Earth is to live within a resonance of forces vast and untamed, and now comes the visitor. By Atlas, fragment of another system, relic of another sun, its path is brief, its presence fleeting, yet its arrival has disturbed imagination, perhaps even the Earth itself. The question rises, is humanity only a witness to these alignments, or is it also a participant entwined in a greater resonance that includes star, planet, and abyss? To some, the answer lies in humility. Humanity is small, fragile, a single species on a single world orbiting an ordinary star. What power could it have in the grand symphony of cosmic forces? Yet even this humility holds paradox, for through its tools, its telescopes and seismographs, humanity has extended perception across billions of light years, has mapped the trembling of space-time itself, has heard the faint echoes of black holes colliding in distant galaxies. To observe is to alter. To measure is to participate. Knowledge itself changes the path of civilizations, and thus the universe that contains them. Einstein showed that observers are never separate. They define frames of reference, and reality takes its shape within them. Hawking reminded that the act of observing the universe is inseparable from the universe's unfolding. In this sense, humanity is not merely a watcher of cosmic drama, but a character within it, shaped by its rhythms and shaping in return. If Earth quakes with the sun's stirring, then perhaps humanity too is part of the resonance, not the cause, but the receiver, the amplifier, the consciousness that turns motion into meaning. The crust moves, but it is human awareness that transforms movement into story, into pattern, into reflection. Without observers, the tremors would still exist, but their significance would be silence. With observers, they become questions, and questions change the world. The fragility of this condition cannot be overlooked. Civilizations have always lived in balance with instability. Ancient peoples told myths to explain why the ground shook, why the sky flared with strange lights, why comets crossed the heavens. Today, myths have given way to science, but the need remains the same: to understand, to place order upon chaos. Fragility drives curiosity, and curiosity is the bridge by which fragility becomes strength. In this light, the passage of interstellar visitors takes on symbolic weight. They may be fragments of ice and dust obeying nothing more than physics. Yet their timing, their rarity, their unsettling presence invite speculation. What if they are not simply passers-by? What if their role in the universe is catalytic, not only stirring stars and planets, but awakening consciousness? For just as sunlight awakens frozen cores, perhaps these fleeting wanderers awaken imagination, compelling humanity to see its place anew. Consider the possibility that each interstellar visitor is a reminder that Earth is not alone in the galaxy's story. That stars too may be stirred, their fields perturbed, their flares awakened, that planets may resonate when a fragment passes near, that consciousness itself, fragile, searching, may be nudged forward, drawn into new questions, new awakenings. The thought is speculative, Yet speculation itself is a form of participation. To imagine connections is to build bridges of possibility, some of which may one day prove real. Science advances not only by data, but by the courage to ask questions that once seemed impossible. What if interstellar visitors are not accidents, but moments of contact with the deeper rhythms of the galaxy? What if their presence is a chord struck in the ongoing symphony of awakening? And so humanity listens to the trembling ground, to the storms of the sun, to the faint flickering light of a fragment drifting past. It listens not only with instruments, but with awareness, with imagination. The earth shakes, the sun stirs, and humanity is spellbound, uncertain yet compelled. In the end, the role may not matter. Witness or participant, spectator or actor. What matters is the recognition that humanity is inside the story, not outside of it. The universe is not a stage observed from afar. It is a field of resonance in which every element, every body, every consciousness is entwined. Atlas will pass, fading back into the abyss from which it came. The sun will continue to storm, Earth will continue to tremble, and humanity will continue to build upon shifting ground. But for a brief moment in cosmic time, the presence of this interstellar fragment has drawn attention to the deeper truth, that the cosmos is alive with hidden connections, that Earth itself may be part of a resonance far greater than itself. And that awareness of this resonance is itself a kind of awakening. The Earth shakes, the sun stirs, humanity listens, and in the silence between tremors, in the pause between storms, the question remains, glowing like an ember in the dark. Are we merely witnesses to the cosmic drama? Or are we participants, drawn into the music of the universe itself?